Hi everyone, my name is Matthias and I'm part of the Tableau marketing team here at Tableau. I'd like to welcome you to our today's webinar about analytics in the cloud with Tableau and Amazon Web Services. Before we start, we have some housekeeping items to cover. We are broadcasting live and recording the whole session, so there's no dial-in. All audio will be streamed through your device. You can adjust your audio by clicking on the menu at the top under Communicate, Audio, and make sure everything is set correct. If you have any questions, type it in the Q&A box on the right-hand side or use the chat window. In this live webinar, you will hear from our customer consultant and technical evangelist, Francois Zimmermann, and Dr. Wolfgang Schulte, Senior System Architect at our partner M2, about how a self-service BI and analytics architecture can benefit from cloud deployment in AWS. With that said, over to you, Wolfgang.
M2 for 2 years as a system architect, and I have many years of experience in the area of big data and cloud architectures. And now I'm head of technology at M2, and I'm proud to present you this webcast together with Francois, and he will introduce himself.
Hi everyone, I'm Francois Zimmermann. So I work as the tech evangelist to our partner community across the EMEA region. So I essentially own the CTO relationship into our tech partners like AWS, but also our system integrator and solution builder partners like M2. And essentially I work with those groups to ensure that we have like viable end-to-end solutions that kind of solve problems with customers.
Okay, then let's start. What we want to do today, we want to show how a self-service business intelligence and analytics architecture can benefit from a cloud deployment in AWS by applying best practices and reference architectures. Our webinar is structured as follows. After a first introduction, Francois has a very nice showcase for you, and it will motivate why it is useful to go to the cloud. And then we talk about success factors, possible next steps, and at the end we will have a Q&A session. Okay, then let me introduce M2 a little bit more to you. M2 provides professional services in the business intelligence space using state-of-the-art technology. With over 8 years of experience in implementing Tableau software, we are the first and most experienced Tableau consulting partner to come out of Germany. And beside our Tableau expertise, we partner with vendors of data integration tool and analytical databases to help you plan, implement, and operate analytical solutions from end to end and provide professional service in project management technology and quality management. What we do is we cover the entire data value chain. We integrate the company's different data sources regardless of the technology used. And we offer a wide range of technologies to consolidate and refine the data. In addition, we have extensive know-how to efficiently display the data in your dashboard. In this way, we help you to correctly process and condense the diverse data in your company and ultimately make the right business decisions. Let me say some words to Tableau. Tableau delivers an enterprise analytics platform that will empower and elevate your people. It will increase the value that they provide to your organization. It also delivers a platform that meets the security governance and scalability requirements of modern organization. What I want to point out for things that Tableau does better than anyone else. You have a powerful analytics that drive better outcomes. You have fast adaptation at scale across all skill sets. and you have the flexibility to leverage existing technology investment, and last but not least, Tableau is a mission-critical analytics platform. And yeah, the Tableau platform provides the depth and breadth of capabilities that ensure that data can be deployed across your organization. This includes capabilities that ensure that the right data is made accessible with flexible data access and powerful data prep capabilities. Solid content and data governance features keep data in the right hands and also ensures user can find the right data and are making decisions based on accurate and trusted data. Powerful analytics, collaborative tools to bring data to the center of every conversation, and Tableau even provides the flexibility to interact with your data in any way you'd like, via desktop, the browser, a mobile device, or even embedded into other applications. And all these capabilities are surrounded by wide security protocols, reliability and scalability to meet the needs of your business. On the other hand, we have Amazon Web Services. AWS is the world's most comprehensive and broadly adopted cloud platform, offering over 165 fully featured services. You can see here at the slide some of them, and this has a range from data centers, globally millions of customers, including the fastest growing startups, largest enterprises, and leading government agencies trust AWS to power their infrastructure, become more agile at lower cost. With using AWS provides customers with a wide range of data analytic tools with the power to analyze vast volumes of customer, business, and transactional data and low cost, and we can rapidly scale any big data application to transform data from kind of systems and customer databases into actionable business and customer insights that helps to drive your business. And now, how M2 helps you to bring both worlds together. M2's role as system integrator is to bring this in a way to both worlds together. On the left-hand side, you have AWS as a strong technology partner that provides all the necessary services to access large amounts of data efficiently. This means that it not only offers the infrastructure, but also ready to use services based on it. On the right side, we have Tableau as a strong software partner for the visualization of your company data with simple and effective concepts. And M2 brings both worlds together has the industry experience to implement the right services to meet the requirements and create successful solutions. This was the introduction to Tableau, M2, and AWS. And now I want to hand over to Francois again with a nice showcase.
Hi all. Guys, can you see my screen?
Yes, we can see it.
Excellent. Awesome. So everyone, I just wanted to talk really, really briefly for 20 minutes or so about how we enable self-service analytics inside AWS Cloud. And specifically what I'm looking at is when customers move from like on-premise data warehouses to data warehousing in the cloud, when they move their analytics infrastructure to the cloud, what they're trying to do is they're trying to get data in the hands of as many people in their company as possible. And so there's kind of two sides to that. The one side is, there's the technical side, but the second side is like most companies, only 5% of the people touch data on a day-to-day basis. So what they want to do is they want to go through some sort of organizational change where they end up with, hopefully like 70+% of the people using data. Hopefully people are using data to make every decision. Hopefully that makes them more competitive. And when we see companies talking about that, what they talk about is they talk about becoming insight-driven businesses. So insight-driven companies or data-driven companies are people that put like data rather than like gut instinct at the heart of every decision. And it's been shown that those companies that do that put data first, grow much faster than their peers. So that's kind of why they're doing it. Now, we think that there's 5 key behaviors that they need to roll out throughout the entire company in order for them to actually achieve that. So in other words, just moving your data to the cloud doesn't get you to the point where you're a data-driven company. You need to actually go through this change where the company culture changes. So firstly, the first thing is companies that are data-driven focus on data literacy. They try and move their everyone away from using static charts and static reports and Excel and static things that are embedded inside PDFs to dynamic reports that people can pull apart and they can kind of question the findings and come to their own new findings. So data literacy is the first key behavior. The second key behavior is that if we want to get everyone using analytics on a day-to-day basis, we need to make sure that the reports that we create, the analytics environment that we create can be accessed from wherever the customers are. So some of the users will only ever touch Tableau on mobile. They will use Tableau every single time they're in a meeting and they need to make a data-driven decisions. Some customers will use Tableau inside business apps like Salesforce, so they'll use it to support decision-making there. And then some users will use Tableau, for example, on the web or on the desktop, and they'll actually use that to pull apart data in new and different ways. So we need to be flexible. We need to be able to meet people where they are. The third thing is not all people are comfortable with interacting with numbers and charts. So we need to have new ways for people to interact and query, and that's why at Tableau we introduced Ask Data, which is our way of providing natural language interaction with data. So people can ask questions of their data in plain text, and they can use that to come to their initial understandings of the data before they start to explore it in more detail using visual exploration tools. Thirdly, companies that are data-driven talk about governance through empowerment rather than like this core of the data stewards that own everything and that you have to go through these gatekeepers in order to access the data. So when we talk about governance through empowerment, the one is have tools that make it effective, that you can assign permissions and give people appropriate controls so that they can discover the data and do new things with the data themselves. But secondly, give them great tools, because if you give people rubbish BI tools, the first thing they do is they take the information out of the platform in order to pull it apart. So they take it into a spreadsheet, and then they start sending the spreadsheets around, and straight away you've lost control of governance. So if people don't love the tools, if people don't love working your analytic framework, you will never have solid governance, because they will immediately take it out and use another tool. And then finally, we have this concept of how do we go and build a thriving internal data community. So we are really, really passionate about building the center of excellence, making sure that people that build great visualizations in companies can share those with other people within their company. We have been the most successful company at building our external community. If you look at what's happening on Tableau Public every day, there are thousands of visualizations that people are sharing with people outside of their organization, with their wider analytic team. And we believe that people need to create the same sort of culture where you have data fans inside companies that are sharing insights with each other on a day-to-day basis. So those are the 5 key behaviors that we think people need to implement within the company. Now, in terms of how we work with AWS, these are the 4 key trends that we see in analytics that we believe that we enable when we work together. The first thing is there's this big trend from IT-led analytics. We have a core of people creating every report to a business user-led analytics, where you still have data stewards, but you enable people in every line of business to create their own insights, and domain experts, so people that understand the models and things that sit underneath the data, to create their reports so that they get the right reports faster and so they can answer every question that they have. We see that when people move from IT-led analytics to business user-led analytics, the amount of volume goes up dramatically. So people start to use the data much more. And the first thing that tends to happen is their on-premise data silos tend to start to creep. So the first bottleneck is typically at the database layer. We typically see that on-premise like data environments that were built for this IT-led business, you tended to see lots and lots of different data silos, and they just weren't designed to scale they weren't designed with the elasticity that we need in order to get all of the business users using the data all of the time. So we see that the second trend here, where people move from IT analytics, we see that drives a demand to move from on-premise data silos to centralized cloud-based data. And at the same time as people do that, we see that when people migrate to AWS, they migrate to use kind of serverless frameworks. So they want to use effectively database as a service in the cloud rather than just run a database in a VM. So they'll use technologies like Redshift. They'll use technologies like RDS. So that they are moving the responsibility for management and scalability to the service provider, and they're able to get much more predictable outcomes. Third key trend is we see people moving from restricted data access to governed data management. So I spoke about this when we were talking about governance through empowerment. And then the fourth key trend is this move from legacy systems to this rich ecosystem of modern cloud-based tools. We tend to see that when people move to the cloud, they also have a think about their entire tool chain. So they tend to look at their data integration tool chain and see whether or not that needs to be modernized as well, because you tend to find that the data integration tool chain is the next kind of obstacle to scale and modernizing and innovating at the speed of business. Okay, so this is what it looks like in practice. Really, when we work with AWS, we ask the question, what is the point in a cloud data warehouse if nobody's using the data? And what we see is inside AWS, you have this phenomenal ecosystem of serverless tools that you can use to provide data services at a predictable cost and a predictable scale, and you can dramatically reduce the administrative overhead of running them. You also have a great tool chain in the data ingestion and data integration space. But all of these tools are really designed for data engineers, data scientists, DBAs, AI gurus to use. So typically, those tools are designed for kind of 5% of the business to use. So they're great for supporting a centralized data culture. What you need is, if you want to roll this out to the line of business users, what you need to think about is well, how do I enable these people to leverage all of these technologies? How do I enable analysts, managers, executives to leverage these technologies to ask any questions? And here what we talk about is two modes that we need to enable. So the first mode is guided analytics, which is there is a requirement for those pre-built gold dashboards, which everyone in the business is going to use to support all their key KPIs. They're going to use to support their key business decisions. And this needs, again, we spoke about this needs to be available within every app, on every mobile device, for everyone in the business to use to make key decisions. But we also see knowledge experts within each of those departments who need to be able to move beyond the pre-canned dashboards and spin up their own insights based on essentially the unknown unknowns, the questions that they didn't know that they needed to answer when they designed the core company dashboards. So this second domain, unconstrained self-service analytics, is just as important, if not more important, because this is where you're going to unlock more competitive insight. But we see it as our job to unlock both of these modes of operation and to enable people to really put data in the hands of as many people as possible. When we work with AWS, we talk about kind of their database freedom program, where they help people to liberate their data from on-premise data silos. And we believe that by layering over the top of that, we enable data-driven business, which is we're moving just beyond just getting your data into the cloud to this point where we actually enable people to use the data in the cloud. And that's really our kind of core business. We have we built blueprints and quick starts and CloudFormation templates and so forth with AWS, really to speed up the deployment and to make sure that we can actually deliver the simplicity we're after. This is the blueprint that we published with AWS. You can see that within the AWS ecosystem, there's a whole pile of services that Tableau can just essentially abstract away. So the business users don't want to see the complexity of connecting to Redshift or Aurora or Athena or RDS or SageMaker. They want to essentially use a single pane that can enable them to connect to all of those services and give them the same analytic workflow regardless of where the data resides. So that means that IT can use the right services for the job, and the business users can use the same tool regardless of where the data resides in the AWS cloud. So that's how we work together. Okay, I want to quickly go through a quick example workflow. I picked this up, which is some wind farm data. And I just wanted to show, I guess, like a quick little end-to-end illustration of how like an end-to-end data pipeline might look inside the AWS cloud. So what we've got here is we have a bunch of wind turbines. They are generating a lot of sensor data. What we've done is we need to provide these two modes of operation in the end. We need to provide guided analytics. So for all the people like the shift managers and the maintenance engineers and so forth, the people that care about the KPIs, how are my wind turbines performing, we need to provide them with a set of highly structured dashboards so they don't have to think too much. Every time they log on to those wind turbines, they need to be able to get the insights surfaced they need in a timely manner. The second domain we're going to illustrate here is unconstrained analytics. So I purposefully created a dashboard that doesn't answer all the questions here, and we're going to go in and we're going to switch modes to the mode of a domain expert. So an engineer who understands wind turbines, who wants to quickly look at whether or not he can get some insights about predictive maintenance from the IoT data that is here. So he's going to quickly build an analysis of predictive maintenance just using Tableau on top of the same data. Behind the scenes, what we've got is these three data sets. The first data set is a list of all the wind turbines. The second data set describes what the sensors are on each of the wind turbines, and then the final data set, which is the data set which is essentially the live streaming data set, is the sensor data, which actually is collected every 10 minutes and actually provides the health and so forth and performance of each of those wind turbines. So let's kind of kick into that and have a look at how that looks. This is when I spoke about that first mode of operation, the guided analytics. This is the sort of thing that people might want to do. Firstly, what we'll probably do is we'll probably take the actual the data about where the wind turbines are, and we'll overlay that over a map. I was surprised when I first received this data set. I thought it was synthetic, but when you zoom in on the map and you can actually you can actually see some actual wind turbines in the satellite photo. It becomes pretty obvious that this is actually real data from real wind turbines somewhere in France. Now, what the maintenance engineer might want to do is they might want to click on a wind turbine, and then they might want to drill down on a particular spike where they can see it's a high wind day, it's a high power output day. Let's see how that wind turbine was performing on that day. And then the next thing the maintenance engineer might want to do is they might want to drill down on the kind of top three components that typically break on an average wind turbine. And then they might want to look into some detail into all of the sensor readouts for that particular point in time, or compare them perhaps to a different point in time, and just see how that wind turbine is performing. So that's this kind of first mode of operation where we talk about guided analytics. Now let's just look under the covers a little bit about how that gets put together, and then I guess we'll start to understand why Tableau is providing some uniqueness there. So under the covers, I'm connecting live to my AWS data sources. You can see I have a list of wind turbines here. Let's just update that. You can see I get all of the details about the manufacturer and the model and all of that. I'm going to be able to use that to build my visualizations. I also have this kind of GPS field here. And Tableau allows you to quickly save calculations with data sources. So in this case, I've broken down that GPS field into latitude and longitude using a quick text calculation. And then I've also quickly broken down that I've quickly created a geographic field so that I can start to plot that on a map. So I've saved that with that data source. So I don't have to change the data in AWS. I just use Tableau to add additional business logic to it. The second table I can see here, again, this is live from Redshift, is the description of all the sensor data. You can see that there's a wide variety of sensors installed on this wind turbine. And then the final data set is, let's just pull back 5 rows or something. The final data set I've got here is the actual sensor data that's been collected from each of the wind turbines. So again, we're going back into Redshift and we're pulling back this data live. So give us a second while that loads. Okay, there you go. So you can see it's quite a wide table. It's got lots and lots of sensor data for each of the wind turbines, and I've pulled that in. Now, in my visualization, what I'm able to do is I'm able to show data from a variety of different data sources at a variety of different levels of detail without having to build multiple views inside Redshift. So this first view is actually built from the first table I showed you, which is the location of the wind turbines. The second view here is built from the sensor data, but it's rolled up to daily level. And then this third view here is built from what I've done here is I've drilled in on the window that's shaded in gray. And these metrics here are shown at the most granular level. So these are shown at the 10-minute level. And I've done all of that without creating multiple views inside Redshift. So I'm using the data as it is. It makes it simpler for me to iterate. It makes it simpler for me to come up with the right views. Now, if I move from that first mode where I'm doing guided analytics to the mode where I want to do something more smart. So I'm a guy who really knows my wind turbines, and I want to go and build a predictive model. What I might want to do is, for example, look at the efficiency of my wind turbine. So if I look at the specification for these, where have I gone? So I've lost my mouse. Oh, here we are. If I look at the specifications for this wind turbine, there's an expected power curve for a normally behaving wind turbine. You should see a correlation between wind speed and power output, and that's kind of intuitive. So what I might want to do if I want to start to explore that is I might want to test that correlation myself. So I can quickly pull in all the sensor data from those wind turbines, look at how those are actually performing according to the compared to what the manufacturer's specification is. When I look at that and I look at one of these peaks, I can see that some of the points are outside of my predicted specification. So I know that probably means that one of these wind turbines is in need of a little bit of love. And so really quickly inside Tableau, what I can do is I can build, in this case, it's a polynomial regression curve that quickly highlights, which of these wind turbines is behaving abnormally. In this case, I can see this one R80711 needs a little bit of love, and I can go and potentially save this as an insight for multiple people to work on, and then the rest of my business can start to use this to determine when something is likely to fail. Okay, so that was a really quick little demo. I just wanted to take you through that just to show you the power of end-to-end guided analytics and unconstrained analytics with Tableau and AWS. So now I'm going to pass back to Wolfgang. Thanks very much.
And now can you hear me? Yeah. And now the question is, how do I bring these great dashboards to a broader audience? And essentially, you need three things. You need a Tableau server, then you need a fast database, and a process for loading the data. And if you look a little bit back into classical hosting, then you will recognize that it is complex. It has a time-consuming order and installation process. You have to order the hardware, and you have install all the things on the hardware. You have to wire all things together, and so on. Then, when it is installed, it is hard to change the system configuration later on. Then you will have high personal costs for administration and maintenance. And last but not least, it is a very inefficient hardware usage. The system is designed to proper handle peak requests, but running on low level most of the time. And you usually over provision your system configuration to fit the customer's needs. And yeah, often it takes weeks until the system is running. From a global perspective, the available hardware can be used far more efficiently with cloud computing and virtualization. What are the motivators for cloud computing? First of all, scalability and performance. Broad bandwidth of concepts for more challenging use cases like auto-scaling, failover, and inter-region replication of whole environments comes with cloud computing, and it is very easy to up and downsize your resources. Second, you will have very easy multi-environments on demand because resources are immediately available. So it's not only the servers are virtual, but also the entire infrastructure, and it can be replicated at will. The third is resources allocation based on usage patterns. The environment itself allow detailed monitoring of all components of the data value chain, and this makes it very easy to identify and eliminate bottlenecks. And the last is speed to market. The environments are immediately available. They are ready to use templates for different use cases. Let me show you a little bit how the data is usually formatted. If you start, then you will usually have heterogeneous unstructured data. And this can be Excel files or complex database schemas or CSV files, whatever. And these data must be brought into a uniform data format. And then if you have this common data format, which is also called what's also in the staging layer, then they can be loaded into a highly efficient data layer, which can then be accessed by Tableau, very performant. And as you can see, the whole chain is already supported by Amazon services. As Francois mentioned, you have a lot of services like S3, a cheap storage, or to collect the data. You have Kinesis, a service to handle data streams very efficiently, but also for preparation and provisioning. There are a number of services that can be used directly. With Redshift, for example, you have a ready-to-use BI database that can efficiently deliver large amount of data to Tableau. And last but not least, you will have EC2 instances not only allow you to host cost-effective the Tableau server, but also other products, third-party products for data preparation. And yeah, at the end of the pipeline, you will have the Tableau server with pre-aggregated data, and this will give you the ability to host your dashboards in a web application. When a customer asks us what it takes to get the Tableau server online, two things are essential: users and the users and the data sources. The question is, how many concurrent users do you expect, and who are these users? Are they internal or external users? It's obvious because more users need bigger hardware, but it also depends on what the users are doing. Do you have web editing users or only users that consuming dashboards? And furthermore, what kind of data they processing? Do they have live data connections, or is it more extract handling? And all of this is important to design the Tableau server later on. And the other question is, what are my data sources and how do I get the data from there? And there is the question, is the data in the cloud? Is it internet accessible? Or do I have data sources on premise? Or do I have a combination of them? And then you will decide whether or not you need further data integration services and or a data hub. And as more data sources you will have, it makes sense to have also a BI database or a data lake to structure the data and to leave the Tableau server resources. And yeah, what are the successful factors here? We have identified 3 successful factors: security and governance, scalability and performance, and operational efficiency. And I want to dig now a little bit deeper into these factors. First, security and governance. If you make your dashboards available to a wider audience, security and governance is obviously very important. The important question that needs to be answered are who accesses the system and who is allowed to see which data and what are the processes like. And all this has technical implications for the design and the architecture of the infrastructure and the configuration of the hardware. Furthermore, responsibilities must be named and processes are defined. And if you think about all these questions, then you will probably see that you will end in an architecture like this. But don't be afraid. This picture should only give you an impression what you have to consider if you want to host an integrated Tableau server environment with all security relevant questions. In this environment, for example, Amazon components for reliability and regular backup are built in. In addition, there's a secure connection between the cloud resources and the data sources in the on-premise network. And finally, components are implemented to monitor the system. And the good news is that all the components already present in the Amazon stack and only need to be configured correctly. And as we see later, all this can be easily modelized and scripted. And I will give you a short example. We've implemented at Thomas Cook. The customer has a number of different data sources on premise, on the internet, in different cloud environments with different responsibilities, including third-party providers and so on. And the Tableau server is used by different divisions with partly sensitive company data. And data security has a top priority for this customer. And in order to guarantee this, we have implemented various hardware and software concepts. On the one hand, a special VPN connection was necessary due to the many subnets of the customer, which could not be covered by a standard service. We used a standard appliance from Cisco here. And on the other hand, a security concept was developed and implemented to isolate and secure the company data in the Tableau server. A second success for the factor is scalability and performance. The free scalability of the resources is one of the greatest benefits of cloud environments. Together with detailed monitoring, it allows me to flexibly adapt my resources to actual requirements and identify bottlenecks. And not only AWS offers a variety of monitoring options, Tableau has also implemented various performance analysis options. And with the outcome, you can easily scale your systems in the cloud. And you have there generally two options that are also Tableau supported by Tableau Server on software side and AWS on hardware side. You can horizontal scale and vertical scale. Horizontal scaling means that I simply increase or decrease the number of my hardware nodes, often the only option for bare metal installations. As more nodes, as faster the system will be. In most cases, and especially with complex software, however, this connection is anything but linear. More often it has a logarithmic correlation. This means that the increase in performance decreases steadily for each additional node, and at some point it is zero. It's obviously if I add one additional node, it has no effect anymore. Better in this case is vertical scaling, where the hardware is simply enlarged. This means that I increase the parameters CPU, cores, memory, hard disk, and I/O throughput. This only works very limited for bare metal installations in cloud environments. However, this is easily possible and only requires a reboot of the system. And vertical scaling is only limited by the maximum system size provided by the cloud provider and the money you bring along. In Amazon's case, this would currently be 484 virtual CPU cores and 12 terabytes main memory. This is, from my perspective, more than enough for most Tableau server installations, I guess. And yeah, what is the perfect size of a Tableau server? Anyone who gives you an exact answer on this is probably lying, because the point is that it depends on many factors that are unclear at the beginning. In the end, it is an educated guess. The good news is, however, that the number of expected users is already a good starting point. Tableau gives you a lot of recommendations how to size, and then with a good monitoring, you can optimize the system successively by monitoring important parameters like CPU, memory, and I/O over the time. And if we have this information, we can give you a good advice, and yeah, then you can save a lot of money without annoying the users by a bad performing Tableau server. And here we had a case study at Axel Springer. It was not clear from the beginning how the system would be used and accepted by the users. In addition, new users should not be immediately deterred by a slow system. And it was not only the Tableau server, but also we also had to migrate the BI database into the cloud. And what we've learned from the old system was that the database was a bottleneck most of the time, and we migrated the legacy system, including the database, to a Tableau server on a Redshift database. And with fine-grained monitoring, we were able to continuously optimize the system and thus ensure the availability of the service to the satisfaction of the their users. And the last success factor are operational efficiency. It is true that as higher the availability of the system should be, as more technical actions are needed. For instance, you need backup and recovery strategies. You need upgrade and security patching strategies. You need a fine-grained monitoring and detect system and the ability to detect system failures before the service becomes unavailable, and you have to monitor if the system has enough resources to fulfill the performance requirements and so on. And you also will have fault-tolerant strategies to cover service level agreements. And everything together must be serviced, and it becomes more complex if then the environments need to be replicated. For instance, if you need a second testing environment or a third environment for development and so on. And also, furthermore, you only want to pay probably the service that is really used. For instance, if you don't need the test environment all the time, then you don't want to pay for it. And in this case, you can always reinvent the wheel, but with the cloud, you have the possibility to describe whole environments as templates, and you can roll out them automatically, and in the end, a stack that seems complex at first becomes very easy to handle, since each task can be described and reused as a modular building block, and these modules can be combined to individual environments according to the customer's requirements. And it is also possible to replicate finished environments one by one for test and development purposes. What I now want to do is I want to show you a short video how this scripting works. We at M2 use Terraform to script the whole environment, and it's just to give you an impression. What you need is, if you have these modules combined together, you need to enter some registration information. This is the same what you would do if you install your Tableau server manually, and then you give some technical information like the machine size and where the configuration files for the Tableau server are laying on, and then you can start applying the infrastructure to the cloud. And what Terraform here does is checks if what parts of the infrastructure have to be redeployed. And in this case, we need 60 items to deploy on the cloud, which are, for instance, IAM components for identity and access management. We have S3 storage for the data. We have system manager services and the Tableau server itself with security groups, subnets, routings, and so on. And last but not least, the monitoring components. And when the system is hosted, you can see it here in the Amazon console. Then you can go to the CloudWatch dashboard to monitor the system, and then it takes a while because after the instance was created, it deploys itself, the Tableau server, and then if it is finished, then you can log on to the Tableau server and you can work with it. And as you can see, all the content is already deployed with no additional manual steps needed. And as a case study at AIDA, um, it was a core requirement not to make brownfield deployments anymore. Brownfield deployment means that the version upgrades are always performed at the same machine, and this has a risk of long maintenance windows. If something goes wrong, then you can't. You have to stop production during that time. And instead of that, new Tableau versions should always be rolled out and tested on fresh new hardware before going to the production. And this is also called greenfield deployment. And only if everything is okay with the new environment, then we switch over with the right network infrastructure to the new machine, and this reduces the risk of production downtime to almost zero. Okay, then let me end with next step, what we can offer. If you come to us, ask for Tableau server hosting at AWS, we usually start with a workshop. This workshop will contain comprehensive requirements analysis. Then we will discuss the options for the probably solution, and we give you some recommendations for your BI architecture. And then you have three choices for hosting. We have the first would be supported service. This means that we support you to install and configure your BI environment and provide first-level support by our M2 service desk. The second choice would be assisted service. We deploy the architecture BI environment into your cloud and taking over the operational responsibility. And the last one is full service. We host and operate the whole environment on your behalf. And you can bundle this together with software according to your requirements in three categories: Tableau in AWS installation service, Tableau of the Tableau server in the AWS environment, or Tableau in AWS plus data integration, which means that connection to your data sources will be from the Tableau server will be also included, or the third will be Tableau in AWS plus Data Hub, which means that we construct your BI stack in AWS consisting of a Data Hub. This could be Redshift, Exasol, or Snowflake database with the integration of data lake, in this case AWS S3, and design of loading processes. And all these bundles can be combined with supported, assisted, or full service from our side. And yeah, that's was it from my side. And now I'm open for questions and answers. Thank you.
Thanks, Wolfgang. Thanks, François, for this great presentation. As Wolfgang said, now we have time to jump in and ask questions, and we will answer them live. First question which is coming in, I can answer by my own, is yes, we recorded the whole session and we will provide it to you in the next couple of days. The first question, the next question which coming in is about data leakage. So, what do you do to prevent data leakage for or at your customers?
I'm not sure what you exactly mean with data leakage. I mean, you have many security concepts in AWS to prevent unauthorized access to data. First of all, I would advised to use the concepts which are built into the Tableau server. But yeah, nevertheless, you can also encrypt the data in the whole AWS stack and yeah, use keys, yeah, security keys and so on.
Yeah, it's more a leak.
Yeah, we also have like an ecosystem of privacy partners, so people that do tokenization and pseudonymization. So typically, in order to do most analytics, you don't actually need to see like individually identifiable data, which is where the big sensitivity around data leakage comes from. So usually you can do analytics by knowing about the cohort rather than by knowing about the individuals. And so during the data integration pipeline, for customers that are concerned about that or are dealing with person identifiable data, we see them pushing the data through, one of the data privacy tokenization vendors before it reaches the data lake. The whole point about the data lake is to enable people to ask as many questions as possible. And often, if you store identifying data alongside non-identifying data, then it just means that you end up having to lock the whole thing down. But agreed. The Tableau control contains a bunch of controls that enables you to use, for example, roles and groups to define who can access which visualization and which published data set. So that's your first line of defense. And then also the AWS controls where you can encrypt data and provide strong access controls is your second line of defense.
So I see no more questions coming in. Then thanks for taking the time, Professor Wolfgang, to presenting. And yeah, thanks for attending. Have a great day and bye.
Bye.